Well, here we are, still hanging out in 10.2, little calculus with our parametrics. So we've learned how to find a derivative, the second derivative. Well, shit, let's find some areas, integration, stuff like that. We know what's up with finding the areas. Now we're just going to extend it a little bit. We're going to make it how we do with our parametrics. So let's read. Find the area of the region enclosed by the asteroid. Look, asteroid. Asteroid. Defined by the parametric equations, x equals a times cosine cubed of t, and y is equal to a times sine cubed of t. And it creates that pretty little picture on the right. I'm pretty proud of myself for that one. But we definitely see that we have symmetry all over. And if you want to, you can find the area of all four of those regions, but it looks like they're all the same thing. You know what I mean? I think this up here, this first quadrant, it's going to be the same area as the other four. So why don't we just set it up? Oops. Why don't we just set this sucker up and start going? I mean, we know how to integrate. So let's say that this area that we're going to go find is going to be 4 times the integral of, okay, so we go from, what's that length? So from 0 to a, so the length would be a, okay. So from 0 to a, and then we would do our y values, whatever that would be, right? We'd say like if y was equal to 2x minus 1, I'm going to integrate, we just write 2x minus 1. But let's just write y in here. And then that would be with the derivative with respect to x, right? That's how we'd find the area typically. We'd write our function, dx, yeah? Our bounds 0 to a. Now we're going to multiply all this shit by 4. So let's start plugging stuff in. This isn't that bad, I promise you. We're just going to go 4. We'll talk about our bounds in just one moment. Well, dude, if we only had some sort of y, we only had some sort of y. Why don't we take that and just plug it in instead of writing in y? Let's write in a times sine cubed of t. So we're going to put in a times sine cubed of t. Sim, what the hell? Sine cubed of t. All right, there's y. Now what's up with dx? Shit, we don't have dx. Oh, wait. Dx. Wait a second, we got this x. What if we went through and, I know what to do. Let's just go dx is equal to, that'll be what, negative 3a cosine squared of t sine of t. Sorry, I've done this one a couple times. Just run right through that one and bang, there it is. Oh shit, but I forgot. dt. Why don't we go take that thing and we replace our dx with it? So that's how this game is going to work. You're going to write your y in, and then you're going to multiply. You're going to multiply by the derivative of that x with respect to t. Okay, so where dx dt needs to equal this. So we pop it in there, and it's this negative 3a cosine squared of t sine of t, and I'm going to leave that dt just hanging out right over here. Oh no, but we're going to have to, we're going to have to go find our bounds, aren't we? So we better plug that thing into our function and go figure out what the heck is all these values are in terms of t. So which ones do we plug in? Which ones do we want? How are we going to do this? So we had these were all x values. So let's take a look and see how we're going to change our bounds. Like, this is a pretty tricky little problem. So we're going to say when x was equal to a, we'll say it's from right up here. We're saying that x is equal to a. We'd have a is equal to cosine cubed t. We divide that out. 1 is equal to cosine cubed t. Hit it with a cube root. 1 is equal to cosine of t. Hit them both with an inverse. You're going to find out that t just equals 0. Okay, so that's going to become a 0. Now we're going to play that same game, and we only plug it in where the x is. Now we're going to go now instead right up here. Instead of, go away. So instead of writing in x up here, we're going to put in our 0 to go find that bound. So we're going to say 0 is equal to a times cosine cubed t. We divide everything out, but we're basically saying is where cosine of t equals 0. We're going to hit this thing with an inverse. So we go t is equal to cosine inverse of 0. And that just gives us that one value where t is equal to pi over 2. So we had to change those bounds as well. We got to plug them in, plug those into the x's, because remember, we started off with this thing that we're taking this with respect to x. So those were all x values, a little bit backwards, a little bit funky. Now let's take care of this integral. We're almost there. See this negative that's hanging out right here? Why don't we get rid of that negative? Let's bring all of our constants out the front. We're just going to flip our bounds. So this is why the bounds are going to go over, is we're just going to flip them over. We're going to go 0 to pi over 2, and we're going to forget that negative. Once we rip everything out, we have an a and an a. We have a 3 and the 4, so that's going to become what? 12a squared hanging out front. With a, once you put it all together, I think that's sine to the 4th of t times cosine squared of t dt. Oh no, what have we done? What have we done? Now, let's just start rolling through this, and I think we might have some things, but we've done this so many times, I'm just going to break it on down all the way to the end. Oh, what do we got? Let's plug it on in. This is going to be 12a squared times, since you've seen it so many times before, why should I do this? This is going to be 1/16th t minus 1/64th sine of 4t. Right, clearly, huh? Clearly, but you've already done this before. You don't need to see this done again. You're an old pro with this crap. 2t, and then we're going to evaluate this sucker from 0 to pi over 2. And once we plug in all this stuff, it's going to be fantastic, what you're about to find out. That this is going to be equal to 12a squared times. And you know what this is when you plug it all in? Because I know you can see it, can't you? You can see it. It's just pi over 32. Clearly, right? Could you imagine doing all this algebra? You can, because you've had to do it before. This teacher's made you do it. Once we put all this stuff together, we're going to find out that our answer hangs out in a very clean 3 pi over 8 times a squared. So definitely get your practice with these, because your quiz problem that will be due, your online quiz number 2 is, now hold on, let me find that number, let me rip it out and let's look. It is 10.2 number 28. I'm only going to write it once. 10.228. All parts are due. Put that thing into the assignment and get it turned in. This is the only place you're going to find out about it. Get it done. 10.2.28. Look on Canvas to upload your assignment. This is online quiz 2. See ya.